So our last section is 5.3, solving radical equations. A radical equation is an equation with radicals that have variables in the radicand. So an example would be something like 7 is equal to the square root of 3x plus 1. So you notice you have a variable inside the square root bracket. Extraneous root is a solution obtained in solving an equation that does not satisfy the initial restrictions on the variable. Okay, so does not satisfy the initial restrictions on the variable. It means that it won't be a solution. Okay, and we'll see some of those. When solving radical equations, extraneous roots satisfy the equation after squaring. In other words, you can plug it in after you square it and it will work, but they are not roots of the original equation. When solving a radical equation, remember to identify any restrictions on the variable. Identify whether any roots are extraneous by determining whether the values satisfy the original equation, not the equation formed after squaring both sides of the original equation. This is very important. So when you're going to check your answer, you need to make sure that you plug your answer back into the original equation, not some other work that you've done, okay? Like not after you've squared it or anything. Okay, example 1. Solve an equation with one radical term. State any restrictions on x if the radical is a real number in 5 plus the square root of 2x minus 1 equals 12 and solve. Okay, so we'll first take a look at restrictions. Now we have to worry about that on this question here because our index is an even number. So we need to take our argument, which is 2x minus 1. And we need to make it greater than and equal to 0. And now we want to isolate for x. So you want to go 2x, bring your negative 1 to the right. It becomes positive. 0 plus 1 is 1. Divide both sides by 2. And whatever x is, it has to be greater than a half. Okay, so let's solve. We'll do that over here. So we've got 5 plus the square root of 2x minus 1 equals 12. We want to start by isolating the radical. So that means we want to get the square root of 2x minus 1 all by itself on the left-hand side of the equation. So we need to move the 5 over to the right. And remember, when you do that, it becomes negative. Okay, opposite sign. And so you now have 2x minus 1 equals 7. Okay, so we've done our first step. Now you want to square both sides. So we're going to square the left. We're going to square the right. When you square a square root, the square will undo the square root. So that means that you are left with 2x minus 1. Okay, and then you're going to square your 7, which is 49. Now, if you're not sure about a square undoing a square root, let's look at a simple example over here. Let's say you have the square root of 2 squared. That means you want to go root 2 times root 2. And the square root of 2 times the square root of 2 is the square root of 4. And of course, the square root of 4 is 2. Okay, so take a look. The number that's in your radicand is the same number as your answer. So when you go to square a square root, the square undoes the square root and it leaves you with the radicand. Okay, so let's continue. We want to isolate for x, so we're going to go 2x equals. We want to bring the negative 1 over to the right. It becomes positive, so you get 49 plus 1, which is 50. Divide both sides by 2, and you get that x equals 25. Okay, now it does satisfy our restriction. Our restriction says that whatever x is, it has to be greater than or equal to a half. Okay, but you can still check. So let's check. you want to show that the left side is equal to the right side. So let's plug our 25 back into the original equation. So we'll write the original equation down. Substitute in 25. Simplify what's in the radical. You've got 2 times 25 is 50. 50 minus 1 is 49. Oops, this is plus. And then you're going to get 5 plus 7, because the square root of 49 is 7. And 5 plus 7 is 12. And so you can show me that the left side is equal to the right side. Now, I didn't leave myself much room, so I'm going to get rid of this. Okay. Now, I want to show you that you can determine if there is a solution for an equation using inspection. Okay, so determine by inspection. Okay, and what that means is not by solving. If radical equation has a solution. Okay, so the very first step that you have to do in order to use this method of inspection is to isolate the radical. And then what you're going to do is you're going to compare the signs of the radical on one side and the number on the other side of the equation. Okay, so we're going to compare signs. Now, if you have a statement that reads a positive on one side of the equation and a positive on the other side of the equation, you have a solution, because that makes sense, right? A positive number can equal a positive number. If you have a negative on one side of the equation and a negative on the other side of the equation, well, that makes sense too, so you have a solution. But if one side of the equation is positive and the other side of the equation is negative, there is no solution, okay? Because it doesn't matter, it doesn't make sense. You can't have a positive number equal to a negative number, so no solution, which you can write like this if you like. So let's take a look. We're going to use our example from number 1. We're going to go to the step where our equation was isolated, okay? So we had the square root of 2x minus 1 equals 7. Okay, so that's this step here. That's where we isolated our radical and we bring it down here. Notice that both sides of the equation are positive. A positive number can indeed equal a positive number, so this one has a solution. Let's say, for sake of argument, that both sides of the equation were negative, so we had negative square root of 2x minus 1 equals negative 7. Okay, and so we have a negative on both sides of the equation. Well, it is possible for a negative number to equal a negative number, so you would have a solution for this. But let's say one side was positive, so let's say 2x minus 1. We'll keep that side positive, and we will make this right side negative. Okay, so this side is positive, and this side is negative. There is no possible way that a positive number can equal a negative number, so this is no solution. Okay, so there are questions in the textbook where you'll be asked to determine through inspection whether you have a solution or no solution. Okay, so this concludes example 1. Okay, so in this next example we're going to be taking a look at a radical equation that has an extraneous root. And if you recall, an extraneous root is a solution obtained in solving an equation that does not satisfy the initial restrictions on the variable. In our case, when solving radical equations, extraneous roots satisfy the equation after squaring, but they are not roots of the original equation. Okay? So, what are the restrictions on n if the equation n minus the square root of n minus 5 minus n equals negative 7 involves real numbers, and then solve the equation? So let's take a look at restrictions first. Our argument is 5 minus n, and because we have an even index, we know that 5 minus n has to be greater than or equal to 0. And so now we want to isolate the negative n. That means we have to move the 5 over to the right. It becomes negative. And we cannot consider this isolated until the n is positive. So that means that we are either going to multiply both sides of the equation by negative 1, or we're going to divide by both sides by negative 1. Now, before we go ahead with that, let's review something that we learned from grade 9. Let's say I give you a statement that 2 is greater than negative 3. And I ask you to multiply both sides of this inequality by negative 1. And so negative 1 times 2 is negative 2, and negative 1 times negative 3 is 3. Can you put the greater than symbol in here? In other words, is negative 2 greater than 3? And the answer is no, it's less than. So when you multiply or divide, both sides of an inequality by negative 1, you must reverse the inequality. Okay, so if we go over here, we need to switch our inequality, because I'm going to multiply both sides by negative 1. So negative 1 times negative n is n. Reverse inequality. Instead of greater than and equal to, it's less than and equal to. Negative 1 times negative 5 is 5. So make a note, you're going to reverse inequality. Okay? Alright, so let's solve then. The first step is to isolate the radical. So our equation is n minus the square root of 5 minus n equals negative 7. Now I'm going to move my radical over to the right, because that'll make it positive, and I'm going to move my negative 7 over to the left, because that's going to make that positive, and it's just better to work with positive numbers. So bring the negative 7 to the left, it becomes positive, you have n plus 7. Move the negative square root of 5 minus n to the right, it becomes positive square root of 5 minus n. Next step, square both sides. Okay, and so when I square n plus 7 times n plus 7, okay, and I FOIL it and simplify, I'm going to get n squared plus 14n plus 49. And that's equal to, and remember, a square undoes the square root, so you're going to get 5 minus n. Now, if you're not sure about the n plus 7 squared, it's n plus 7 times n plus 7. So you're going to FOIL n times n is n squared, n times 7 is 7n, 7 times n is 7n, and 7 times 7 is 49. Combine your two middle-like terms, you get n squared plus 14n plus 49. Okay, now notice you have a square. Because we have a square, we have a quadratic. Okay, so you need to put it in standard form. So you want to write the equation in the form of ax squared plus bx plus c equals 0. Okay, so we're going to move the 5 and the negative n to the left, so we're going to get n squared. 14n plus n is 15n, and 49 minus 5 is oops, 45, and that's equal to 0. Okay, so from here you can do one of two things. You can solve for your variable x by factoring if your quadratic is factorable, or if it's not, you can use the quadratic formula. Now this one is factorable. So the two numbers that multiply to give me, oops, this is 44. Sorry, because 49 minus 5 is 44. The two numbers that multiply to give me 44 and add to give me 15 are 11 and 4. And they both should be positive. So positive 11 plus positive 4 is 15, and 11 times 4 is 44. Okay, set each factor equal to 0, and you get that one root is negative 11, and the second root is negative 4. Now, they are both less than 5. Okay, so we need to check. So let's do that here, check. And remember, always in the original equation. So write out the original equation. And you want to show that the left side is equal to the right side. Okay, let's plug in, let's start with negative 11. So we're going to check with n equals negative 11. So plug that in, you get negative 11 minus square root 5 minus negative 11 equals negative 7. So I get negative 11 minus. And inside the radical I have 5 plus 11, right? Minus a negative number means to add. That gives me 16. And I get negative 11 minus 4. And negative 15 does not equal negative 7. So we reject n equals negative 11. Okay, let's check with n equals negative 4. Original equation. Plug in negative 4 for n. 5 minus negative 4. Okay, simplify. Inside the square root bracket we have 5 minus negative 4, so that becomes 5 plus 4, which is 9. Square root the 9, we get 3. And negative 7 equals negative 7, so our solution is negative 4. And you should write a sentence. Okay, the solution is negative 4. All right, and that concludes example 2. We are now going to take a look at an example of solving a radical equation where we have a radical on both sides of the equation. So if you take a look at this one, we have a radical of x plus 8 on the left and a radical of 3x plus 1 on the right. So if you take a look over here at the steps, the first step is to square both sides. So we're going to show that by putting brackets around both sides and squaring our radicals. Okay, and remember that when you want to square a radical, a square undoes the square root, and so you are just left with the radicand. So we have x plus 8 equals 3x plus 1. Now, unlike our previous example, this example is not giving us a quadratic. Okay, so if you notice, the exponent on the x is a 1. So this is linear. So you can start right away isolating x. All right, and I'm going to bring this x to the right, and it's going to become negative x, so that I get 3x minus x. And I'm going to bring this positive 1 over to the left, and it becomes negative, so I have 8 minus 1 on the left. So when I combine both sides, I get 7 equals 2x. Divide both sides by a 2, and you get that x is 3.5. Now, I know here that it says to check your solution by graphing, but we're also going to do it algebraically. And so here is my check. I want to put 3.5 back into the original equation. Okay, remember, always back into the original equation. So I want to go 3.5 plus 8, square root of that, equals the square root of 3 times 3.5 plus 1. So on the left you get the square root of 11.5, and you will get the same on the right. Okay, 3 times 3.5 is 10.5, and 10.5 plus 1 is 11.5, and so you can see that the left side is equal to the right side. Okay, so how do we determine restrictions? Notice we have two radicals, so how do we decide what our restriction is going to be? Okay, well, let's start with our first radical, which is the square root of the square root of x plus 8, and we're going to take our argument, which is x plus 8, say that it has to be greater than or equal to 0, isolate the x. That means you want to move the positive 8 over to the right, it becomes negative, and you get that x is greater than or equal to negative 8. And then we'll do the same thing with our second radical. We're going to take the radicand, in our argument if you like, and make it greater than or equal to 0. Isolate for x. So bring the positive 1 to the other side. It becomes negative 1. Divide both sides by 3, and you get that x is greater than or equal to negative 1/3. Okay, so there's a couple of ways that you can determine what your restriction is going to be. The first way is to choose the larger number. Okay, so negative 1/3 is larger than negative 8, and so we say that our restriction is that x is greater than or equal to negative 1/3. Okay, the second way we can do this is visually. What you want to do is draw yourself a number line and put your two restriction values on the number line. Okay, showing that the negative 8 is smaller than the negative 3 by making sure it's on the left of negative 3. Okay, so if we want to graph x is greater than or equal to negative 8, we use a closed circle to show equal to, greater than, we want to move to the right. And we will do the same thing with negative 1/3, closed circle to include the negative 1/3, everything to the right because it's greater than or equal to negative 1/3. And then what you're looking for here is where do the two graphs start to overlap. Okay, and you can see that they overlap where x is equal to negative 1/3, and so we choose x is greater than or equal to negative 1/3 as our restriction. Now, we can check that this is true. Okay, now what I'm going to show you is not that negative 1/3 works for both of them. I'm going to show you that negative 8 doesn't work for both of them, so we can't choose that one. Okay, so what we want to do is we want to take our negative 8 and plug it back into both of our radicals that we have. The first one being x plus 8. So plug the negative 8 in for x, and you get the square root of 0. Now that works, okay, because you can take the square root of 0. The square root of 0 is 0. Let's plug it into our second radical, which was 3x plus 1. So plug in negative 8 for x. And we're going to go 3 times negative 8 is negative 24, plus 1 is negative 23, and this is not possible. Okay, and that's because it's undefined, because you cannot take the square root of a negative number. So notice that negative 8 does not work when we plug it back into both radicals. Okay, it does on the first one but not the second one, so that's why negative 8 is not a possible answer. You'll find that if you plug negative 1/3 back into both of these radicals, you will get a value. It'll actually simplify to a value. There's no, it won't be undefined. Okay, alright, so we are asked to check by graphing. Okay, and we can choose two ways. One is the one equation way and one is the two equation way. With the one equation way, you want to take your original equation, which is the square root of x plus 8 equals the square root of 3x plus 1, and you want to move one of the radicals over to the other side. So I'm going to move the square root of 3x plus 1 over to the left so that I get x plus 8 minus the square root of 3x plus 1 equals 0. Now remember from our unit on quadratic equations that when we had a quadratic equation that was equal to 0, the way that we would solve it by graphing was to write it in its function form, and so that means we need to replace the 0 with y. And so into your calculator you're going to enter y1 equals the square root of x plus 8 minus the square root of 3x plus 1. Now when you put this into your graphing calculator, you will want to make sure that you have brackets around your radicands. Okay, so when you use the one equation way, what you're looking for are the roots of your equation. In other words, where does your equation cross the x-axis? And you can see that that happens right here. So if you go into your graphing calculator and look for your zeros or your roots, you will find that x is equal to 3.5. And that is in agreement with the solution that we have up here. Alright, if you choose the two equation way, then what you want to do, you want to take your original equation and you want to set one side equal to y1. So I made the left side equal to y1, so I made that y1 is the square root of x plus 8. And you choose the other side to be y2, so I said y2 is equal to 3x plus 1. I entered those into my graphing calculator and I got these two lines where the red one is y2 and the blue one is y1. Now when you choose the two equation way, what you're looking for are your points of intersection. So you need to use that function on your calculator. And we're looking for where the two lines intersect, which is right here. And when you find that on your graphing calculator, you will get that x is equal to 3.5. Now, which of the two methods you want to choose will be totally dependent on what kind of a picture you're going to get, and also which one you're most comfortable with. Sometimes the one equation way doesn't give you a very good picture. You might want to use the two equation way, and vice versa. So it's a matter of a little bit of trial and error, or even preference, because maybe you don't want to move terms around like we do for the one equation way. Maybe you just want to plug in that one side of your equation is y1 and the other side is y2, and go from there and look for your points of intersection. In either case, you may have to choose your own window settings other than the default one on your calculator. Now, one thing that I forgot to discuss. If you take a look at our domain restriction, you can see that our answer corresponds with that. X has to be something which is greater than or equal to negative 1/3, and 3.5 is indeed larger than negative 1/3. So this concludes our discussion for example 3. So this next example is for my honors students. It's a continuation of example number 3, and I'm calling it example 3b. We're still taking a look at a radical equation that has a radical on both sides, but if you notice I have constants on both sides. So it's not a straight radical on the left or the right. You will be following similar steps to our previous examples, but we're going to add an extra step here. The first step is to isolate one of your radicals, then square both sides. So the first two steps here are the same as what we did on our other two examples. But then you're going to find that you're still going to have a radical on one side, so you have to isolate the radical again, and then you will be, I should have added square both sides again, and then solve. So why don't we just write that down. So square both sides and then solve. Alright, so our first step is to isolate one of the radicals. you need to make a decision as to which one you want to do that with. So let's take a look at both of them. If I choose to move the 5 over to the left and it becomes negative, that's going to give me 2 plus the square root of 3x is equal to the square root of 5x plus 4. Or if I choose to move the 7 over to the right, I would get the square root of 3x equals the square root of 5x plus 4, and then 5 minus 7 is negative 2. Now, keeping in mind that we're going to be squaring both sides, you are going to find that it will be easier to square what is on the left on our first choice than it is to square what is on the right on our second choice. Okay, so I'm going to recommend that you move the 5 over to the left and isolate the radical that has a binomial in it. Okay, so we're going to start from there. Okay, so we won't do this one. I'll just cross that out. We're going to work on this one. Okay, so we've got 2 plus the square root of 3x, which we are going to square. All right, and I'm going to use our shortcut for squaring a binomial, so follow along carefully. You first want to square the first term, so the square of 2 is 4. Plus, you want to take the product of the two terms in this bracket, so you want to multiply them. You want to go 2 times the square root of 3x, so 2 square root 3x, and you want to double that, so that gives you 4 square root of 3x. And then you want to square your last term, and that means you want to take the square root of 3x and square it. That will leave you with 3x. Okay, and on the right, you just want to undo your square root. When you square it, that gives you 5x plus 4. Okay, so that takes care of our first two steps. Now we want to isolate the remaining radical. Our remaining radical is 4 square root of 3x. So that means we want to move the 4 and the 3x over to the right. So if I move the 4 over, it becomes minus 4 minus 4 is 0, and if I bring the 3x over to the other side, 5x minus 3x is 2x. Okay, so our radical is isolated. We now want to square both sides again. And you will get 4 squared is 16 times, and then square root of 3x squared is 3x, and then on the right you will have 4x squared. So now you've got on the left 48x equals 4x squared, and we will divide both sides by 4, and that gives us 12x equals x squared. Now please don't divide both sides by x to get rid of the x, because we have a quadratic, right? We have a square on our x here. So the first step to solving any quadratic equation is to make sure that you make it equal to 0. So we're going to bring 12x over to the right, and then we are going to factor out our common factor, which is x. That leaves us with x times x minus 12, and then we will set each factor equal to 0 and solve for x. And so on the first one we get x equals 0, and on the second one we get x is equal to 12. So those are your two solutions. Okay, and as usual you need to test them out. So we're going to check. We will plug the first one into the original equation. So we'll check first with x equals 0. Okay, so, oops, on the left, square root of 3 times 0, and on the right, 5 times 0 plus 4 in the radical. So you get on the left here, you've got 3 times 0 is 0, the square root of 0 is 0, and 0 plus 7 is 7. And on the right, we have 5 times 0 is 0, 0 plus 4 is 4, the square root of 4 is 2, and 2 plus 5 is 7, so that one works. Now we will plug in x is 12. So on the left, you have 3 times 12 is 36, and the square root of 36 is 6, and 6 plus 7 is 13. On the right, you have 5 times 12 is 60, 60 plus 4 is 64, the square root of 64 is 8, and 8 plus 5 is 13, and so that works too. And so the solutions are x equals 0 and x equals 12. Okay, and just like on example 3, you can use your graphing calculator to check your answers, so I'll leave that for you to do, and you should get the same solutions, x equals 0 and x equals 12, regardless of which of the two equation ways that you work it out. Okay, so that concludes solving equations. Our last example for 5.3 is an application problem. What is the speed in meters per second of a 0.4 kilogram football that has 28.8 joules of kinetic energy? Use the kinetic energy formula E subscript k equals 1/2 mv squared, where E subscript k represents the kinetic energy in joules, m represents mass in kilograms, and v represents the speed in meters per second. Okay, so we want to know what the speed is in meters per second if the mass of a football is 0.4 kilograms and it has 28.8 joules of kinetic energy. Okay, so a good place to start is to write down what you know. You know that your formula for kinetic energy is E subscript k is equal to 1/2 mv squared. You know that the mass of your football is 0.4 kilograms. And you know that your kinetic energy is 28.8 joules. Okay, and I'm going to show you two ways to work this out, and you're free to use whichever way you would like. Okay, on the first method, we will start with our formula. And what we want to do is we want to isolate the variable that we're solving for. Okay, and because they want to know what the speed is, and you know that v represents the speed in meters per second, that means we want to solve for v. Okay, so the first thing that you might want to do is to get rid of this denominator. That means you want to multiply both sides by 2, so that on the left you now have 2e subscript k, and on the right your 2's will reduce and you're left with mv squared. Then isolate for v squared by dividing both sides by m, and so that leaves you with 2e subscript k over m on the right, on the left, and v squared on the right. And then you want to square root both sides because you need to isolate v, and that leaves you with v is equal to the square root of 2e subscript k over m. Now remember, when you square root both sides, one side should read plus or minus. Okay, and we're going to make the left plus or minus. Now you only want to consider one, either the positive or the negative, right? And you only want to consider the positive simply because you can't have a negative speed on a football. So we will only consider v is equal to the square root of 2e subscript k over m. Okay, so we have v isolated. We want to plug in our values that we know. We know that our mass is 0.4 and our kinetic energy is 28.8. So into our formula, we want to put 28.8 in for e subscript k, and for m, you want to put in 0.4. And when you work all of this out on your calculator, you should get 12. Okay, our second method is to start once again with the formula. And you want to start right away by plugging in your numbers. So in place of e subscript k, you're going to put 28.8. In place of m, you're going to put 0.4. And you will leave the left as is right now. You are going to go one half of 0.4, which is 0.2. And then you're going to divide both sides by 0.2. And you will get 144. And then you will square root both sides again. And don't forget to put plus and minus in front of the square root of 144. But remember, when you square root, remember that because we're looking for velocity, you only need a positive velocity, so you don't need the negative 12 when you square root the 144, so your answer is 12 equals v. And remember to, when you square root the v squared, a square root undoes the square, so you're left with v, and so your answer is v equals 12. And so you should end with a sentence. The velocity of the football is 12 meters per second. And make a note here to choose only positive velocity. So i.e. positive 12 meters per second. Okay, so that finishes off 5.3 and it finishes off this section, or this unit.